Hello and welcome to this new tutorial, and in this tutorial I will show you how we can perform digit recognition using deep neural networks. So this is what actually I want to achieve, and once the model is loaded we can draw something like, let's say, 7. When I apply it, now you can see that this is the 7, and the probabilities, although there are small probabilities, but the probability of being 7 is very high. Let's say we can try by drawing a 4, and then you can see the probability of 4. So let's get started. I have already configured the project using Emgu CV 4.4. If you don't know how to configure it, you can check one of my previous videos. The first thing that I will show you, the model that I'm going to use is from the Open Neural Network Exchange, and you can go to the models. There is already a pre-trained network on MNIST dataset. So inside the vision and inside this classification, and there is an MNIST dataset which has already been trained, and you can download any of these models, and I'm just going to download this OpenSet version 8. So I'm going to download this 26 KB. I'm not going to download the test data. So this is what my pre-trained model will be, and I'm going to use this model for the testing purposes. Since I have already downloaded it, and which I will keep as it is here, I have already downloaded it, so let me delete it. So this is the MNIST 8.ONNX model. So this is already pre-trained model which I will be using. So let me go to the project and add a new submenu item, call it DNN, and inside it I'm going to write it in MNIST classification recognition, and double click on this. In fact, I'm just going to create a new form. So on that new form we will be working on digit recognition. So I'm just going to add a new form here. Right click on the project, go to the add, and into the form we can give it a name like form MNIST recognition. Okay, so when I click on this button or the submenu, we can open that form. So form MNIST recognition form is equal to new MNIST recognition form, and just I want to show the object form.show dialog. Okay, so that's it for this part, and what I want to do here in this form, I will ask the user to basically draw an image draw some digit using the mouse, and then we will try to recognize it. And before the recognition, the user has to load the ONX model. So I'm just going to use an menu strip, and let me call it file, and load ONNX. So double click on this. I'm going to write a try catch. If I have any error, I will throw an exception. And then with the help of an open file dialog, let's say dialog is equal to new open file dialog. And this time we are going to use only the .onnx filter, so that we can only select the files with this extension. So ONNX files, we can write the description like star.onnx, and I'm going to copy. You need to write a pipe here and then write it like this. If dialog.show dialog equals dialog result.ok, it means that the user has selected a file, then we can load it. By the way, I can create a variable to store the model. We call it first using emgu.cv, and then using emgu.cv.structure. And since I'm using the deep neural network, so I need to include that as cv.dnn, deep neural network. And inside this deep neural network, we have a model class called the net, and I call it the model, and initially let's say this is null. And now I want to read the trained model into this model class. So model is equal to DNN invoke, so deep neural network functionality. We can use the methods inside it, so which we call it read net. So this one will basically read the net, but I'm going to read the net from the Open Neural Network Exchange, so ONX model. So this is the method that I'm going to use, and then dialog.file name. So once we read the model, maybe we can give a message somewhere here on the top. Let me drag and drop a panel also, and we can set this panel to doc parent. And inside here, I'm just going to put a label on top here, and we can say this is LBL message. And once we load the model, we can show a message dot text is equal to model loaded. Okay, so once the model is loaded, the next what I want is, maybe we should set this one equal to nothing. Next, I want the user to basically draw an image here, and that image of the digit we want to recognize it. So I'm going to drag and drop a picture box. And this is enough, I guess, or like this. And then I need two buttons. One is, let's say, to clear this one. I can say that clear. And another button that I want is to apply the recognition. So let's say apply. And one more label that I will put on top of it, or maybe somewhere here, that once we recognize what kind of digit it is that we recognized. So let me LBL digit, and after recognition we will display it right here in 12, and we don't need anything right now. Okay, and another label that I can write on top over here, and then we can say that draw a digit 0 to 9. So the new user will be able to draw some digit over there, and then we will recognize it. Okay, so that is the basic structure that I just want to use. And now I need to apply some mouse drawing events. So the first thing that I will also do is to change the border of this, maybe the background color of my picture box to be white, and also I want the border to be, let's say, single. Okay, so that's it. Here is my drawing surface. So with the help of the mouse down event and the mouse up event and the mouse move event, I want to draw the digits here. So what I am going to do is click on this picture box, and I'm going on this mouse down event, and I need basically two variables. One is the point that is basically pointing to the start position where my mouse is down, and let's say this is equal to point.empty. And another, I need a boolean to indicate that my mouse is down or not. Is mouse down? And by default I set this one equal to false. So when I click on the picture box when my mouse is down, then I can set start position equal to e.location. So here is where my mouse is down, and also is mouse down is equal to true. Okay, and the next event that I need to define is the mouse up event. So double click on this mouse up event. So when my mouse is up, what I need to do is mouse down is equal to, I am going to make it a false, and start position is equal to point.empty. And while moving, I want to draw it, so I need to go to this mouse move event. So when it is down and it is moving, then I need to actually draw the digit. So here the first thing that I will make sure is, let me write it the try catch. The first thing that I need to make sure that my is mouse down equals true or not, and my start position should not be equal to null. So it means that the mouse is down and we have selected something, and then I want to check if my picture box one dot image, if this equals null, it means there is no image. So I need to create an image, and then I will draw on that. So let me create a bitmap and call it bitmap. Bm is equal to new bitmap, and here I can give basically the size of the image that I know. The image will be the same size as my picture box. What is the width, and the picture box one dot height, and then we can set this one to be picture box one dot image is equal to bm. Okay, and then we can, using the graphics object, we can draw the graphics. So let me call it graphics g is equal to graphics dot from image. So we have this image in the picture box one dot image. Okay, and I want to draw on it. So what I want to draw is a filled ellipse, let's say ellipses. I want to draw it, and we can use a brushes dot black color e dot x, where we want the x position, e dot y position, and then let's say we want to draw an ellipse of 15 height and width to be 15 15. It should be y. Okay, and one more thing that I want is image.smooth mode is equal to smoothing mode dot, let's say, anti-aliasing. Okay, and to redraw the picture box, after this one I want this picture box to be redrawn. So to do that, we say picture box one dot invalidate. In fact, I don't think we need also the position, because I'm not going to use this one, and let me comment it in fact if we do not need it. Okay, so that is what we hope, that it will draw the some sort of number. So let me try it first. Okay, so the first thing here in DNN, MNIST recognition, and if I try to draw it, so this is what exactly I wanted. So when I clear it, it should go away, and also maybe I should change the pointer to some other also, and we can clear it. Okay, that's great. So the first thing that I want to make is I need to change the cursor. So here I'm going to change this cursor to be across, and when I click on it, I want to clear this picture box. So if picture box 1.image is not equal to null, I have an image, in that case is equal to set equal to null, and also we can invalidate it, picture box dot invalidate, and maybe we can also do the dot digit dot text. If we have recognized a previous digit, we want to reset it also. Okay, that's awesome. We loaded the model, we cleared this one, we can draw it. Now it's time to recognize it. So double click on it. In here, I am going to write a try cage first. The first thing that I need to make sure that I have some picture in my picture box or not. Dot image equals null. Then we can throw a new exception. Let's say draw a digit, and in fact I can show it in label message dot text is equal to ex dot message. Okay, and the second thing, our model should also not be null. So model dot, if model equals null, then again I will show a message, throw new exception, load the ONNX model. Okay, if both are okay, then we can convert whatever the user has drawn on this picture box into a bitmap, and then we use that bitmap to pass through the deep neural network and see what kind of digit it is. So the first thing that I will make is a bitmap. We call it bitmap is equal to new bitmap, and again this should be the same as picture box dot client size dot width, whatever the width I have, because the client may change on the rendered size may be changed. So client size dot height. Okay, so that will be my bitmap, and now I want to draw this picture box dot image and draw to bitmap, and this is what I want, bitmap. And the next parameter this one is asking is bitmap dot client rectangle, whatever the size of this current picture box it will be, I want to draw it with the same size as my picture box. So once I read this drawing that we have written on this picture box into a bitmap image, and then I can convert it into my EmguCV image. So let me call it img, and we can do something like this, bitmap dot to image. So here I'm using BGR. In fact, we don't need the BGR, it is just an image, so I can call it the gray, and byte should be small bytes. Okay, so I converted that into a byte. And also one more thing, our background is white and the text that we have written will be black, so we need to invert it so that our text will be white and the background should be black. So I will perform a not operation also, and to make sure that there is no any problem, so I want to just smooth it using a small Gaussian kernel of size 3. And one more thing that we should know from this MNIST model, when I go to the classification in MNIST, it is already written here that the input data should be of the size 28 by 28. So we need to reshape it. I mean, I will do the reshaping later, but whatever the image I have, I will resize it into a 28 by 28. So that thing I will do dot resize, and we need it to be 28 by 28. And what kind of interpolation technique we are going to use is, I'm going to use cubic for better results. Okay, and by the way, we can see the picture in picture.image is equal to img.isBitmap. So let's see what after resizing it looks like. Okay, and DNN, MNIST recognition, and now I draw an image, something like this. And when I click on apply, first we need to load, of course, load the ONX model. So we first need to load that model. And that model is basically present right here. And remember, I'm using this 8. So I open it, and when I say apply, so this is the image that we will pass to the model. So okay, that's great. And one more thing for the MNIST 8 is we need to normalize it, or by dividing it to 255 by 255. So I will also do that here. So this is the best option where I can do it. I can do a multiply by 1 divided by 255.0f. So it should be a float division. Okay, so this image is in basically Emgu CV format, but we need to convert it into a tensor. And the tensor should be like 1 by 1 by 28 by 28. So we need to reshape it into a tensor form so that I can pass it into the DNN. So to convert it into this tensor form, what we can do is, I call it input is equal to DNN invoke dot blob from image. So this is what we need to generate a tensor using blob from image, and here I can pass my image as input, and that's it. So it will generate the tensor in the form that the network is accepting. And for the model, I need to set the input. What input that I am going to take is just an input. And we take the input, and the next step will be just to model dot forward. And once we do the model dot forward, it will pass our tensor through the network, and it will give us the scores for each digit, that what was the accumulated output for 0, 1, 2, 3 up to 9. So there are 9 classes. And remember, this is basically a mate, so I'm going to write it output is equal to the output that I have received. So this will be essentially a 1 by 10 mates object. You can see here 1 by 10. So because there are 10 different classes, and these 10 classes are basically the numbers. We can find the maximum, for example, what is the maximum output, and then we can select it. Before that, I just want to convert this mate into a float array. I call it array is equal to new float, and of course there are 10 possible classes, so I call it 10. And then I can say output dot copy, and we are copying it into array. And here what I can find is the maximum index. What is the maximum probability of what is the label which has the highest score, let's say. So I can do something like this: label a message or label digit.text is equal to whatever the highest index that I have received. So we can find the highest index or highest value by using array.index of, and here we are providing this array, and what is the maximum value here? Array.max. I do not need the max value actually, I need the maximum index actually, and we can say dot to string, or maybe I can do something like this, int index, and then we can do this index dot to string. Okay, So this will be probably, this is the index that we are receiving, but this the forward will give us not the probabilities actually. So this one will give us the score. So this is what it is saying, that the likelihood of each number before max. So what is the likelihood that we have? Is it 0, or is it 1, or is it 10, or is it 20? And as a post processing, I will show you how we can pass these results through a softmax and convert them into probabilities. But right now, let's see what the scores likelihoods are telling us. Based on that likelihood, what is the maximum likelihood of a number, of a digit, and then I'm just going to pass obtain that. So let me start again, and MNIST, load the model first, and I'm going to draw some digit, and then I say apply, and this one shows that this is 7. Clear it. Let's say this one, what says, it says 5. Okay, I don't need to do that again. Okay, let's say this one, so this one says 4. Let's say if I draw 3, it says 3. Okay, so it is working. So now I want to convert that one, instead of using the scores likelihood, I want to convert that into some probabilities, and based on that probability we will decide what is it actually. So I don't need the small picture, so I just want to comment that. So how can we convert it into probabilities? We need to define basically a softmax function. So what I'm going to do is I'm going to define a private, and this one will return float of an array, and we call it softmax. And this one will take another float array as input, we call it array. And over here what I'm going to do is, as you are well aware of this softmax function, so this is what we want to calculate. We need to calculate the exponent of all the elements in the array and sum them up together and divide every element by that sum. So that I'm going to do right now. This method is going to calculate that. So variable exponent for all the individual elements that I am going to do is from a in array. Let's say I'm going to link query, select math dot exponent. We want to calculate the exponent of every element of a, and of course I need to convert it into float. So I need a float, and of course I want to execute it right after I completed it, or I can set to array. Okay, so this one will find the exponent of every element in this array, and the results will be in this exponent. And now I also need the sum of all these elements, so I can call it sum of exponent dot sum. So whatever the sum we had, we calculated, and now it's time to exp dot select. I'm just going to use this lambda expression x divided by that every element will be divided by the sum, and again convert it into array, and this result we want to return it. So we applied the softmax for all the elements in the array, and let me call it from here. So instead of finding the index like this, I want to find the highest probability, and based on that probability we will decide which kind of digit is this. So let me say probability or scores, or probability, let me write prob is equal to softmax, and we are going to pass our array all the elements or all the likelihoods that we obtained, we passed into this one and it will convert into probabilities. Now I am going to find out the index from the probability. Instead of, let me uncomment it here, and instead of using this array, I want to find out the probability, and I want to find out what is the maximum probability, and then we show that index is the highest probability. And optionally, what I can also do is, this will be the digit that we show, and if you want to draw the probabilities using, there is a chart object, a component which we call it the chart. Where is the chart? So we can draw a chart also if you want, and let me select this one, and a series that I want to show, let me call it the series to be hist, or maybe we can change from there, and x value types will be integers and y value types will be double. Okay, and also I just want to remove this legends, so I just want to remove it. We don't need to show the legends. So here we will show the probabilities, and here I want to show the classes and their respective probabilities. So what I can do here is, so chart 1 dot series, if there is any series, I just want to clear all of them, because maybe we will be doing it for multiple charts, and chart 1 dot titles dot clear, and then we can write chart 1 dot series, and remember that I put a series that, let's say we add a new series and I call it like hist, and the chart 1 dot titles dot aid, we can say here that probabilities, and then loop through all the elements in our probabilities and show them in this chart. So for I is equal to 1 and I is less than prob dot length, we can add it into chart 1 dot series, and in which series we want to add is the hist dot points dot 8. And here I have both x and y axis, so I will put both the values. On the x I want to show the index, that is the label, and also I want to show what was the probability for each label, and that's it. So let us run it and see the results. So in the DNN I'm going to click on that, load my already trained model, and once the model is loaded we can draw something like, let's say 7. When I apply it, now you can see that this is the 7, and the probabilities, although there are small probabilities, but the probability of being 7 is very high. Let's say we can try by drawing a 4, and then you can see the probability of 4. Let's say if we draw a 3, handwritten 3, so you can see the probability of 3. And let's say we try to draw a 9. Okay, now you see there is a confusion. I mean, it's very low. I mean, for it say things like it is 7, but it is not. If I try for 0, it's okay. If we try with the 8, it is okay. 1, let's say it's 1. Okay, so this is how we can use the deep neural network ONNX model to recognize the handwritten digits. So I hope this tutorial helped you to better understand the image processing with EmguCV. Hope to see you in another video.